Hello, there's the sound. Most welcome to this Material Depot seminar on the theme What Matters, which is a project that was carried out in 2018 where we matched together 10 local designers with the 10 material researchers at the forefront of their field to experiment and collaborate together during 6 months in order to see the full potential within new material development and to visualize often complex research through a design perspective. The results of these exciting collaborations were shown in a group exhibition at Dutch Design Week in October in Eindhoven for the very first time. And now the exhibition is presented here at formdesigncenter upstairs until 7th of March, I believe. Since the exhibition is now here, we wanted to give you some more insight into the collaboration. So we have a couple of the participants from the project here today. They will be joining our panel discussion, moderated by Jasmine later on. But first, we have invited designer Marjan van Aubel here today. She will be giving you an inspirational lecture. But some practicalities perhaps before we start. Emergency exit is behind this curtain. We will have a short break between the lecture and the panel discussion. And if you need to find a toilet, it's upstairs on the 2nd floor. Please turn off your cell phones. We will be streaming this event, so we don't want to hear any signals from your cell phones during lectures and speeches. And once again, welcome.
So to introduce today's inspirational speaker, who we are very happy to have here today, Marjan van Aubel is an award-winning solar designer based in Amsterdam. And her work spans within innovating the fields of design, technology and sustainability. And as an energy pioneer, she has worked in collaborations with scientists, engineers and institutions to promote extreme efficiency through design. And for this reason, we thought that she would be a perfect inspiration to all of us, because this is right on topic of what we've been working on. So we're happy to hear the inspiration from her work. So please give a round of applause for Marjan.
Well, thank you for having me in this beautiful location here in Malmö. Like I say, I'm a solar designer and I work from extreme efficiency. That means I work with materials that expand in size, or work with solar cells that use the properties of colors to generate electricity. To explain this image over here, these are lab samples of solar cells. I will explain this to you later. So you could say I have 2 fascinations. So there would be solar cells. So if I go on holiday, I take photos like this, and foaming materials. That's Let me start with the foaming materials. I try to insert in this presentation also to the collaboration I had and how this material came about. So it's not like, okay, I've done this and this and this, but really who I collaborated and how that worked. So here you see a foaming porcelain. And if you're familiar with making porcelain, but mostly that it shrinks in size. But this porcelain that kind of expand in size and 300%, like a kind of bread or cake making. So I was working in the European Center of Ceramics in the Netherlands. I was doing material research. I was looking for porcelain you could put one time in the kiln, so you don't have to glaze it. Firstly, you make the body of clay, put it in the kiln, then you apply a second layer in the second fire. But they thought, what if you could just combine those and have it in one fire? So we're basically looking for something like that. And these were some of the results. So kind of like a lot of mistakes here. But if you enlarge a mistake, you have something, you can work onto something. And if you're able to repeat that mistakes, you have to work kind of like in a scientific approach and like really map what you're doing and be able to duplicate that. So this is it working? It is growing, right? So it is filmed in the kiln, and you can see there's a little cake or bread. It's expanding, and it will drop out. So then I thought, okay, you have this like weird material that expands and stuff. So what can you make with this? So I basically looked for the biggest thing you could make with it, so see how big it could go. At this European center, there were kilns that you can actually go with a car inside. So this was my graduation from my BA at the Rietveld Academy in Amsterdam, where I studied first. And here you can see it. Here you can see it just coming out of the kiln. So it was a kind of big cake I made, and it didn't work in the first time, but I learned a lot from this, how you have like breakages and things that go wrong, but if you know that and learn from that, change the cooling process or change the kiln temperature, you learn from that. So I would say in material research, 90% fails. So you have to be motivated and keep on making mistakes and be okay with it. So these are some of the first products I made. And then I did another residency at, I hope I say it well, Guldegård in Denmark, where I spent also another 3 months just doing material research and looked at other qualities of the materials, see translucency, and really try to be able to sort of form the bubble size. So if you had bigger bubbles, you could see through more it. And created some new objects, so you could use it, for example, for light panels, or has it other aesthetics. So this is an example of a light called moonlight, where you see these kind of like lunar appearances. Like I said, I like foaming things because you just need a little bit and it expands inside. So it's quite an efficient material. As I said before, I like efficiency. This is a product, something I did at the Royal College of Art, where I studied with Mauricio and Hilda. He's sitting here. And there was like a first assignment, and we was to make the most out of an IKEA, tell the story about an IKEA table. So I just stripped it apart and see how many tables I could make out of one table. And just by mixing things and cutting it up, I was able to make 7 tables out of this one IKEA table because of the expanding. And so there was, okay, I've got something here, which a material I would like to continue working with. So this is the start of another project called the Well-Proven Chair. And there was a collaboration with designer James Shaw and AHEC, the American hardwood company. And they had the question of, okay, can you do something with our wood? So I'm going to show you a tiny film that explains how this started. Because I became an expert in wood chipping and shavings.
So we went around all the different machines in the furniture factory, and we collected the different types of shavings that we could find there. It was about the mixture of these that we used that gave us the perfect recipe, the perfect combination for making our chair.
So like fine particles and like bigger, and that combination is like what we need. So what we do is we add wood chips to resin, a bioresin. We add a bit of water, and that starts a really bizarre foaming reaction.
And this reaction causes the mixture to, is it double or quadruple in size?
Well, I think three double.
Three double?
Three double.
It grows a lot. But the different mixtures make a big difference, you know. We did some tests where it was growing like 600%, but this would be maybe not quite as strong, so we did a mixture in the end which didn't foam quite as much as that.
This is fast forward.
And then when you got your mixture, you just apply it to the mold. It gets a bit crazy then. It's kind of all trying to seep down, seep out of the way, and you just got to keep on pushing it back up with your hands.
So it's a super fun process to work with, because every chair is like completely different, because it really depends on the temperature or where you are, like how much it grows, and that makes it also very exciting to work with these chairs. And you can really see how the material kind of like grows. So the first idea was to, when you make the legs, you use the shaving of that to make the top of that. So you can really, basically, as you saw, it really grows onto the structure, and you don't need any nails or screws, or that's just how it forms itself. So you can really see the behavior, and I think it's very simple. And here we see okay, what if you collect the different type of woods? So you have walnut woods, and that we make into like a tiny collection. So Jamie and we went on a lot of research trip, because we got both kind of addicted to these foaming materials. So this is a research trip to Stromboli, the volcanic island in Italy, and we were looking at volcanic rocks and how you make basically foaming stone. So what was funded by the Future Art Trust. So we just could go there and do whatever with foaming rock. And this is basically, I'm just showing you some nice impression. I show you this picture because it had one solar panel and a lighthouse on it. So I love this tiny island. So we brought a lot of tools and started, went to a volcano and started collecting all these stones and really seeing like how actually does this volcanic rock exist, So it's really can see how the water and the wind and the speed of this stone like create itself, and how the whole island. I'm just showing some holiday pictures here, but how really these minerals and earth forms itself, and we started cutting them up, measuring them. And thinking, okay, we're doing material research here. So what do you actually do with this? So I took a bit of this sand, because everything is black there. Also, so the sand was also black, and I started making glazes out of this to see, what can you do with this? And that was super unpredictable, because you basically have no idea what is in this glaze and stuff. But it's that's why I also wanted to show you this, that we kind of went back to making chairs. Because it was like we realized that if you do something like that, it's nice to work with a geologist, because we basically didn't have enough idea to work with. And we were very good in making foaming woods, and I know exactly how that worked. And we learned from also doing that and really were able to control the foam really well, and became masters in something really weird as collecting foam of a wood dust, adding bioresin and making that to chairs. So that was also something we learned. That if you collaborate, you have to work with experts. You can't just go to an island and think, I'm going to do material research. Then I also would like to show you something else. That went too fast. Another fascination. Oh, there it comes. Which is the sun, and also what you can do with this, with the sunlight. That's why I would like to show you another tiny film.
Honestly, you do not want to be here right now. It is the hottest I have ever felt in London. It's all because of that building beside me. Jim Watterson is a reporter on City AM. He's just cooking up some lunch here. I can't even lift it up, it's actually that hot. He's just fried an egg here on the streets of London. He's just putting that in there for his story. It is so hot. It is so hot. There you go. He has just cooked that egg on a frying pan on the streets of London. If we just look back down there, our cameraman Jim, those tiles have just popped off in the heat. That's how hot it is. It is like being under a magnifying glass, and we need to get into the shade actually. We have with us a solar physicist who is Dr. Simon Foster. If we can just kind of squeeze this. This street in London is rapidly becoming a tourist place.
This is ridiculous. Luckily I've come dressed for it, but it's focused down here. The building behind us is focused down. I've never felt heat like this. I stupidly left my bag out. And you probably see, so this is actually, it got up to 92.6 degrees.
That's Celsius.
That's Celsius, so that's how hot, as I say, I left one of my boxes out that actually contained this, and that's how hot it gets. You can't believe how hot it is. It's actually really unpleasant to
Simon,
actually be out in it.
You're a solar physicist. Just explain this to us, because I've never felt like this in London.
So it's basically, it's like a satellite dish. When you've got a satellite dish, it converges or forces radio waves down onto a point, and then you've got your transceiver at which you receive them. Now you can do the same with light, and that's what this building is doing. Basically you've got a vast area that's collecting sunlight, and it's focusing it down onto a tiny point, which is where we're standing. So all that sunlight that's hitting that building is being focused down here. It's like being under a magnifying glass as a kid, you know, when you could burn stuff. That's what we're in. It's like a giant version of that, and we're feeling the effects. It's really deeply unpleasant.
I'm sweating here.
Yeah, I like what he said, that, okay, all these buildings are constantly there, and it's just like constantly getting this sunlight the whole time. So, and that this solar cells are a way of harnessing this energy, and solar cells are actually invented in 1958. This is not invented, but produced for the first time in 1958. They were invented in 1800 something, and they were made of gold and not efficient at all. But if you think about the development of that has been, this is the first satellite that went into space, the Vanguard. And this is the first telephone call that was made by solar cells. This is definitely in the 80s. And if you think, I was Googling solar design, and then you get things like this. And this is in China. Yeah, but for the last 60 years, if you look, scientists all over the world have been focusing on making solar cells much cheaper. So you see the price of solar has dropped enormously. And also the efficiency has increased a lot. Now solar cells even have an efficiency of 30%. But if we think about the image of solar cells, that has stayed the same for the last 60 years. It is still this technology that is just kind of like stacked onto something, onto roof, and is not very integrated into the building or its surrounding at all. And I think that through design you can really think of like how to have a better effect and how to integrate that better. And I'm going to show you some example of how I do that and with who I collaborate with. So for example, this is collaboration I did with Swarovski and the crystal company. And if you cut crystals in a certain way, if you cut there, you're able to bend and direct the light onto a certain point. So I use the crystals as a lens to focus it onto a solar panel, making them more efficient, because if the light would come like this, it would kind of miss it, but now it's like focusing onto the solar panels. These were powering chandeliers called cyanometer. So you literally could take the solar panels, solar crystals, outdoor, put them near the window where the light is, bring them indoors, and put them into these docking stations. So you're literally taking the sky or the light from outside indoors. And I think if you think about Swarovski and crystals, you think about these like shiny things, but they also develop other kind of crystals. This is an opal crystal, and they work similarly as the sky does. So when you have blue sky during the day, and if the sun drops, it becomes a bit more orange. So it was from like really looking at the material crystals to see how can you use kind of unexpected qualities of the glass itself, of the crystals, to create something new and work with light and see how the light behaves in that. This came about because they always have a sort of award called the Design of the Future, and they pick 3 designers or architects each year, and you could have an exhibition in Basel where the idea was of this year that we created something together. So really I had to work with architect Jimenez, and he used waste crystals to make architecture. And Sotoche, he was 3D printing 3D crystals. And the nice thing is now that I'm still collaborating with Swarovski, and we're taking these light into production. So it's started as a one thing, but now, you can. So it's also interesting for me to see the process of making one product. Also, making a lot of them is a different process. But I got really hooked to solar when I saw this technology. They called it dye-sensitized solar cells. And they use the properties of colors to generate electricity. So you have different colors. So for example, red is more efficient than, for example, blue, because it has a different place in the light spectrum. So if I hear this as a designer, so you have a colored, transparent glass that you can just look through, that is able to harvest electricity, and it looks beautiful. Then I think, okay, where can you apply this? You can basically, anything can be harvesting energy or can be a solar cell. And this is the basic idea how I did my graduation project at the RCA. That basically, if glass can harvest electricity, then this could harvest electricity. This is the energy collection, and in each glass there is this dye-sensitized solar cell. So it's sandwiched between the glass. And if you don't use your glass, you put it in this cabinet, and the cabinet then stores the energy. So from the side, you can there's a USB port. You can charge your phone or power light. Well, these were quite small, and the energy that it generated wasn't not like super big, but it started for me as a sort of like a movement. Okay, then what else could, with more surface, could harvest electricity? So, for example, a table. This is a current table where the whole tabletop consists out of these these colored solar cells. There are USB ports on the side where you can plug your phone through, and it's really designed from aesthetics and efficiency. So you can see here the orange solar cells. We use that because orange is a very stable color for indoors. So that's the reason why I choose to have orange solar cells. But also the pattern is like, if you ask an engineer, okay, how would you design it? He goes from the most efficiency, but still you have room to play with that. So this has the patterns say something about leaves, structure, photosynthesis, the electrons passing through. It still tells something more than just being very efficient. And I'm quite proud of this because it's we also developed an app, and because that's always the most asked question I get is, okay, so how many phones can you charge from this? And then before I go into this complicated answer of, okay, that depends where the table is, how much, is it next to a window, is it even cleaned up, because if you have a lot of stuff, it also doesn't work very well. So the table has now light sensors that reads the light intensity of the room. So you literally, through the app, you can follow how much light is receiving, how full the battery is. And we literally see how light is being transferred into electricity. I didn't do this alone. This is at Instrument Product Development. This is a company in London that really thinks about manufacturing. So you can make one prototype, but it's different to make a lot of them, like I said, with Swarovski. So we really thought of ways of how to duplicate this into a larger volume. And this is when we first launched this table, was at the V&A, the whole team. And it was I learned a lot of I thought, okay, let's make an app, but I didn't know, okay, you need a front web developer, you need a back end, you need someone that makes the connection from the Bluetooth to that, and blah, blah, blah. So it was more complicated, but also with collaborating that you learn and, yeah, you see what actually needed to make an app, because I didn't have any idea. So basically, you could say, I'm thinking, I put objects to work. So a table doesn't have to be just a table anymore, but it can also function as a power source. And this you can do in any scale. This is current window, and we replaced all windows in a gallery in London, in Greek Street in Soho, with these current windows. So people from the street could come and charge their phone through the window ledges. Yeah, like I said, the more surface you have, the more energy you can harvest. And I'm basically saying how much I like solar cells, but I don't even have solar panels myself on my roof. One, I live in the center of Amsterdam. It's like a monument, so it's not allowed. Two, I don't own the house, so I have no idea how to do that. So I'm really thinking, how can we make solar cells more accessible and available for everyone? How can we have a better access to solar cells? And it's not only in the house, but also on a larger scale. So I was literally in the train, driving through the Westland, in the area in the Netherlands with all the greenhouses. And then I saw all this glass, and I thought, what if you could combine traditional farming together with high-tech farming and see what kind of impact that would have? So came up with this idea, is also a little film.
The world's population is growing, and so is the demand for food production. New technologies make controlled farming more efficient, but require a lot of energy. Every hour we receive enough sunlight to provide the world with enough electricity for an entire year. What if we could tackle both our world's energy and food problem? What if we can grow using the power of the sun, but more efficiently using high-tech farming? Power Plant is a self-powering greenhouse. Through a transparent solar glass, it powers its indoor climate. We are now able to grow food in places where this wasn't possible before, such as rooftops or places without access to electricity. We need to rethink the future of farming. Through solar design, solar technology can be integrated much better into our environment. We believe in a positive future and the power of design. We want to make a difference by growing the plants of the future.
This started as a very big idea, like what if we can change all the greenhouses now, and what kind of impact would that have? And I spent like a year talking to farmers and people in the Westland with these big farms, and a lot of scientists at the universities, of seeing, the simple question is of like, okay, how much light is coming for the solar cells, but how much light is coming to the plants, you know? And those are all things you can calculate. And also the farmers there, they think about cents instead of euros or Swiss kroner, right? So it's really like they say 1% less light means 1% less profit. So they're not super keen on these innovations and stuff. So they really want to see profit, and big scale. So it's an industry that's a lot of things are happening, but also super hard to change. So we've figured out where would this make most sense, because where can you use the power of design also in a way where we would actually we can see it and where it makes sense. So that's why we chose for like the urban environment, and think about this big new Kew Gardens, these big greenhouses where people could come and learn from these high-tech technologies. So this is one first prototype we made. So you could literally go inside and experience how hydroponics, which is a way where water is pumped around in the system, and it's powered the lights, which you save 90% of water usage in compared to traditional farming. And the solar cells that you could see in the film are basically embedded in the site, so you don't see them. And that was also the biggest compliment I got, is, okay, where are the solar cells? And that's when I think design really works, if it becomes invisible and so natural part of it, you don't even see it or notice it. Because if you really know it, it's either very good or very bad, or so it's, yeah, I think it's good when you don't see it. And yeah, this is the hydroponic system where you pump around this nutrified water, and you use these colored LED lights, which you can really now program how your tomato wants to taste. If you say, okay, I want my tomato to taste like this and this and this, you add the right nutritions, and you can adapt like the blue light, which is for like the flowers or the fruit grow very well, and the red light is for plant growth. So it's kind of like observed how we can control our food. But like I said, that requires a lot of energy. So this could be a solution of thinking how to combine those. And this is where we showed the first power plant. It was at the Design Biennale last year in London. And you could literally for the first time could come and see how that is. And I could have wrote a report about this, because I have like so much information and so many opinions about it, but it was very important for me to also make a prototype and invite all those people back I spoke to and really experience this and talk about it when you're like there. And of course not everything worked perfectly, and a lot of like mistakes still, but as a first thing, you learn just by doing. That's why I think just making the prototypes and designing it works very well. So this is, I collaborate with architect Emma at the University of Amsterdam. We had some students that were into plant physiology, solar researchers that helped us making all these calculations, and the new institute in Rotterdam that is makes bridges between industry, art, and design and architecture. And I thought also maybe it's nice to show you what I'm working on now. I have nothing to show because it's not there, but it's nice to see what kind of like questions I have. I'm collaborating at the moment with the ECN, that's the Energy Center of the Netherlands, and they are the solar research center of the Netherlands. So I'm going more into fundamental solar research. I could actually learn how a solar cell is made, and I'm kind of going back to the more traditional solar cell, because I've been exploring all these new technologies and they just came out on the market, and I hear all the time like, that's great, but we're not ready to produce on a big scale. And these solar cells are very efficient and they work, and they kind of like are so well developed that they're now they're very cheap because China is producing them on a large scale, and they're super efficient. But now they see nobody wants them, like I said in the beginning, because who wants these ugly panels on their roof? So they actually also are very interested to work with designers, and they really think about integration. And you can see this old-fashioned industries changing a bit and changing their focus. So this maybe I explain you that's the middle is a lens, because if you have a glass solar cell, it also means you're reflecting the light. So that means it's less efficient. So how can you create a nice surface that absorbs a lot of light, but also is nice, looks good, and is efficient. So here a bit of about, I don't know if you're interested in how the different types of solar cells. So from now on you can recognize what kind of solar cell it is, because if it has the corners cut out, it means it's made out of one crystalline piece. And crystalline is a very pure, it's purified. And if you have the multicrystalline, it means they kind of shaped it up and put it together again. So it's, but you see still both a lot. And what the industry is working on now is, like I said, is thinking about what is the integration. This here, what you see there, is a solar panel, but then designed by engineers. So if I see, they show the potential. They see all like, okay, we can do whatever it is. But I can see a lot of potential in it. And the idea of, okay, if you it's so efficient already. It doesn't matter if you work with print and stuff, and then you change 1% efficiency because it fits in the environment. You can do whatever with it. So you want to have it on your house, and the more you have of it, the better it is. So the question of having this tiny solar cell on your roof because it's super expensive is not valid anymore. And also it becomes an old question. Okay, how efficient is it, and what's the price? That's an old-fashioned question in solar cell land. So here, you see, you can now print on solar cells and really work with patterns. And that's what I'm doing now. I don't have any photos of it yet because I'm working on it, maybe the next presentation. But that's basically, what I'm working on, if I look around now, I see every surface as an opportunity to harvest electricity because everything around us can be transformed to a solar cell. And I say I believe in solar democracy, where solar cells as much as possible. Yeah, thank you very much.
You so much. That
a lot,
was
right?
extremely interesting. I think we still have time for some questions from the audience. If anybody has any questions for Marjan, I'll run around with the mic.
I remember you started being interested in this because of the blueberry pigment in solar cells. I don't know if you talked about that in your presentation, and I was wondering maybe you should.
Okay, I could. I'm always afraid. I can go into so much details, so you have to draw a line. No, this inventor of the solar cells, the dye-sensitized solar cells, it's based on on chlorophyll in plants. So the green pigment in plants, and he found that out of blueberries has a similar effect, and he was able to duplicate that effect, that sort of the light is hitting the electron and puts that into motion, and that's normally it would happen just once, but could repeat that? So that basically creating a voltage. So he started with just making solar cell from blueberry juice, and I remember at the RCA I was also doing that, and they just grinding up blueberry juice and making solar cells and titanium dioxide layer, and they worked for a couple of days, and it was great. The efficiency was very little, but it was super. That was the start of his invention, and then he developed it with more. Better dyes that would sustain longer. So they now have a lasting time of 20 years even, so not a couple of days. So now the companies all over the world are making these dye-sensitized solar cells that basically come from blueberry juice. Yeah.
So cool. And does anybody else have any questions? The floor is free. Yes.
Thank you, very inspiring, and also for your deep research into the materials. I had a question about the chair, actually, because I had some students who wanted to work with polymer. What did you call it again? Resin, yeah. So, and they didn't find it. In theory, they found it, but not in any companies. So I'm just curious if you found it in Holland or in the UK, or
it started in the UK, but it was one man that started making that, and he sold it, and then we had to chase all the time this one man that had this weird bioresin that worked very well with how we made it, and then I think it went to France, and then also a bit in Switzerland, but now it's based in France.
Okay, so
but it was super hard to follow this man.
Yeah. And what's the bio in it? Is it derived from trees, or
it's
do you know?
Yeah, it's sort of linseed oil, but also sunflower oil, and it has to do more also a lot with the chemical process before the thing, because it still goes very fast. So yeah.
Thank you. Does anybody else have any questions? Yes, over here.
Thank you so much for your presentation. It was very inspiring. I'm wondering, so you said in the end that you will try to work only with fabrics that are more available right now, or is it something that you want to do in the future, focus on creating something that can be mass-produced quickly in the near future?
Yeah, I'm going through different processes. So with some of the solar application, that would be nice in a bigger scale because then you have more impact. But also nice to, yeah, it's different layers it has. But yeah, I would like to work with IKEA.
Does anybody else have any questions? Over here.
Thank you very much. It was very interesting. I was just wondering what kind of materials are in solar panels, or is it like very? Can you find it everywhere? Is it like special metals and so on? And how can you recycle them? Because this is, of course, also if you think of the life cycle of your products, basically.
Yeah, there I showed a couple of different technologies. I know the most of the dye-sensitized solar cells, but now I'm also know a bit more at the crystalline, and that's the crystalline itself is quite difficult to make because it has to be so pure and has to absorb as much as light. But the dye-sensitized solar cell are basically 2 pieces of glass with a layer of titanium dioxide and sort of sandwich in between. So the titanium dioxide works as a nano layer for the dye, and you could take that apart. So these cells are way better for the environment. And now they also started with the sort of more traditional solar cells to think about ways of how to give them a reuse or take them apart, because they didn't consider that before.
Any last questions before we have a short break? I have a last question for you then. As you've been working a lot with scientists and engineers, it would be very interesting to hear your perspective of, as a designer, working in the field of science and the different sort of points of view that you have as a designer contra scientist, maybe.
Yeah, I think it's similar to engineers or scientists. You have I think 2 types. One is they really go, okay, this is how it is, and they go this step by step. And the other one is the crazy one that wants to try things out. But it's also very interesting to convince the first one to do things differently. And that's a very interesting way of working, because you hear no all the time, and then suddenly it's okay, but we can try it, and then you have something. Yeah.
Well, thank you very much. A round of applause again.
Thank you.
So now we will have a short break, I think around 10 minutes, and you can have some more beers and snittar. And then we're going to continue with a panel discussion up here in 10 minutes. Thank you.